Let's read. From a lighthouse 70 meters above sea level. I'm going to stop and I'm immediately going to draw something. Okay? It says 70 meters above, so that's an up-down thing. Okay? So 70 meters, right? And the lighthouse is at the top of that thing. Okay? A ship 1.2 kilometers out to sea is observed. Okay, so the ship. Is the ship going to be up here, or is it going to be down here? Why is it down here? That's correct, but why? Good. Okay, so number one, the lighthouse is up. Number two, it's a ship. It's a ship, so it's at sea level, right? So, well, okay, I'm assuming it didn't say a helicarrier, all right? So anyway, 1.2 kilometers out to sea. What's the angle of depression from the lighthouse to the ship? Okay, so from the lighthouse to the ship. Okay, I might even just label quickly ship and lighthouse. Okay, did you want to say something? Yeah.
Maybe I think I'm skipping a couple steps, but don't you have to convert them there to 70 meters and 1.2?
Okay. All right, good. So let's note, right from the get-go. The way it sounds.
S-O-H-C-A-H.
Hey, Sapir, why don't you maybe just hold on and not interrupt everyone else?
I was asking Luke, and you sort of looked up weird, so I wanted you to know what we're talking about.
I always look at you weird. Anyway, okay. Hold off. Give me a few minutes. Okay. Tom's mentioned a great point, which is that this is in kilometers, right? And this is in meters, and because they don't match, right? Yeah, I've got to convert. I've got to convert because I'm going to be in trouble later on if I try and mix different units. Okay, so good. I'm going to pop that on my diagram, right? Now, I'm after an angle. What angle am I after? Ali, you got your hand up?
Like, because we know them two, so that being adjacent and the bottom one being opposite.
Okay, pause for a second. We're going to start getting onto the labeling of which side is which, but we need to know where the angle is first, right? Okay, now, it's going to be up in the lighthouse, right? Here?
No, above that.
Why not? Why isn't it here? This looks to me like the angle from the lighthouse to the ship. What's the problem? Where else would it be?
And next to the ship.
Do you reckon it should be here?
No.
It should be on the right angle.
Next to the
Or should it be here? Why not? You know? Okay, now, where is the angle supposed to be? The answer is, out of these three alternatives, none of them. None of these is the angle of depression. Okay?
Wow.
For starters, right? This guy down here, at least if I've drawn it reasonably, is going to be 90 degrees every single time, right? So that's not a question. It's just 90. This is a bad option because that's not an angle of depression looking down. That's an angle of elevation looking up, right? So it can't be this one, yeah? Now lastly, it's not this because, look at where this angle is. Can you see it's measured from a vertical line, right? Like a vertical line from here, okay? But we said angles of elevation or depression are from, well, where are you normally looking? Like, where are your eyes normally facing? And the answer is horizontally, right? Toward the horizon. Yeah? Okay. So there's a line which is missing from our diagram which we need to include, and that's where the angle of depression is. Okay? Alright, now, I was a bit mean to you in that even though that's the angle up there, actually, even though this is accurate, it's not helpful. Right? Why isn't it? What do we need to do to this? That's not helpful like that. Okay, yeah, I need this angle inside the triangle, otherwise I can't do trig on it. How are we going to get it inside? Yeah.
It's an alternate angle with the ship.
Fantastic. Okay, so you can see there's the Z there, isn't there? Right? It is a backward Z, but it's still the shape we're after. So alternate angles actually does put theta in there. This is interesting, right? Do you notice? Angles of depression and angles of elevation, they actually are always equal, no matter what situation you've got, because they've always got these parallel lines. Okay? Great. Now we're done. We've got it inside. Sokotoa. So which ratio do we want here?
10. Why?
How can we tell?
So what?
How can we tell?
I think it's an opposite.
How can it opposite?
This is the angle I want. The 70 meters is opposite, right?
So it was.
Okay. And then this one down here is adjacent. Opposite, adjacent, that's tan. That's tan. Okay. So now I can write my sentence. Tan of, I should always say, oops, degrees. Tan of the angle, right, that's going to be equal to 70 over 1200. Not 1.2, you'll get a really different answer. You put down
Are we
1.2.
doing -1, sorry?
Alright, so I'm going to get to that in a second, right? That's my next line. That's my next line, right? So I'll say now tan to the, now the right way to read it is tan inverse. Even though it is a -1, don't confuse it. So anyway, there's my fraction in there, and then you go for your calculator. Yeah.
In the calculator, you don't have to put the closing bracket, do you?
Yeah.
So I would always put the closing bracket. Sometimes you can get away with it, but if you don't mean to, and then you do some stuff afterwards, your answer will be wrong. Like if I do this, don't leave the bracket in it, and then I have to do some other stuff, it'll all be included, and I don't want to do that, right? So I think it's always safest. Yeah.
The answer. Oh.
Yeah. Let's get the answer.
86.
What?
What?
No, it's 3.3.
Wait, hold on, stop for a second. Tell me what the answer you've got on your calculator is. I'm curious.
So that's what I did wrong first time.
86.6615.
Okay.
I did that wrong the first
All right, now let's just pause for a second. What's going on? You've always got to do this, and this is why it's important. This is why I didn't want to stop you. Okay. This number looks sus to me. Okay. Because 86. What kind of size angle is that? Like that's pretty big, right? It's close to 90 degrees. Okay. Now my diagram is not to scale, but this angle is smaller than 86 degrees. In fact, it should be even smaller. So what's gone wrong, and how can we not do it next time?
He instead of doing like the opposite and adjacent, he did it the other way around, so he swapped it.
So you're saying
So it's 1,000.
we wrote down this? Is this what you're
Oh,
saying?
yeah, I did.
If we did this, tan theta equals 1200 over 70. Okay, good. So this is really, it's great that we notice this, because what does this mean? Because this 86.66, right, by the way, that's actually a useful angle for something else. Where is this angle? It's not just wrong. Where is it?
It's in the
Oh
inside.
yeah, here it is. It's 86.66 up here, because that's opposite and adjacent for this angle, right? So I'm really glad we got to notice that sometimes you can get an answer and you can see something's wrong, and that tells you, okay, I should go back, right? So when you noticed it and you said, no, that's wrong, you fix up your working, and then the answer is 3 and 20 minutes. And you got some extra stuff which rounds off and you don't need to worry about it. There's your answer.
Yeah.
Okay. Make sense?
Got it.
Yes.
Cool.